Right now, as you read this, our entire galaxy, every star you've ever seen, every planet, every atom of everything you've ever known, is being dragged through space towards something we cannot see. We don't know what it is. We don't know how big it is. We only know that it is pulling, and we cannot stop it. That's just one of the places we'll visit tonight, a place so massive and so invisible that moves entire galaxies the way a drain moves water, silently, inevitably, toward a center that remains hidden. But that's not even the scariest stop on this journey. Tonight, we are going somewhere the laws of physics don't apply, somewhere where light itself cannot escape, somewhere so empty that placing our entire galaxy inside it would leave us completely, utterly, unbearably alone for hundreds of millions of light years in every direction. We are going to the places the universe hides, the places that don't make sense, the places scientists lie awake thinking about, because understanding them would rewrite everything we thought we knew about reality. Some of these places will make you feel small, some will make you feel terrified, and some will make you question whether the universe we can see is only a fraction of what's actually out there. Fasten in. This journey has no safe return. Before we go anywhere, we need to understand something fundamental. The universe is not what you think it is. Most people imagine space as a kind of dark ocean, vast, yes, but mostly filled with stars and galaxies spread evenly across the infinite expanse, a billion lights scattered like sand across an infinite floor. That image is completely wrong. The real universe looks more like a sponge, enormous walls of galaxies stretching across hundreds of millions of light years, threaded together into what astronomers call the cosmic web. These walls and filaments are separated by something far more unsettling: voids, vast yawning pockets of mere perfect nothingness, where almost nothing exists at all. And the scale of these structures is not something the human brain was built to process. 1 light year, the distance light travels in an entire year, is roughly 9.5 trillion kilometers. Our galaxy alone is about 100,000 light years across, and the structures we're about to explore dwarf even that. Here's what makes the universe truly terrifying. Most of it is completely invisible to us. The matter we can see, stars, planets, gas clouds, entire galaxies, makes up less than 5% of all that exists. The rest is dark matter and dark energy. Forces and substances we cannot directly observe, cannot sample, and cannot explain. They make up 95% of all reality. We are, in a very literal sense, blind to most of the universe. And in that darkness, some of the most extraordinary and horrifying things imaginable are happening right now, billions of light years away. Some of them may be happening closer than we'd like to think. Let's begin.
The Great Nothing, the Boötes Void. In 1981, a team of astronomers led by Robert Kirshner set out to map the distribution of galaxies across a section of the sky. It was routine survey work, the kind of thing that produces interesting data charts and gets filed into academic journals. What they found instead stopped them cold. In the direction of a constellation called Boötes, there was nothing. Not a little less than expected, not a quiet corner of space. Nothing. An enormous spherical region of the universe, spanning roughly 330 million light-years across, containing almost no galaxies at all. To understand why this matters, imagine filling a room with sand. Now imagine finding a beach ball-sized pocket inside that sand that's completely empty, clean, hollow, like someone had reached in and scooped out everything that should be there. That's the Great Nothing. They called it the Great Nothing, and the name fits perfectly. Where there should be thousands of galaxies, based on everything we understand about cosmic structure, there are only about 60. 60 lonely islands of light floating in an ocean of absolute emptiness. If you placed our Milky Way inside the Boötes Void, you would see no neighboring galaxies for hundreds of millions of light years in any direction. That kind of loneliness is beyond human comprehension. Scientists believe the void likely formed from the gravitational effects of the early universe, smaller voids merging together over billions of years into one enormous hollow. But even that explanation feels unsatisfactory, because the Boötes Void is larger than our models say it should be. It's too empty, too clean, too precisely hollow. Some theorists have whispered darker possibilities, that the void hints at an unknown cosmic phenomenon, that the universe has pockets of missing matter we can't account for, that our models of how structure forms after the Big Bang may be fundamentally incomplete. The Great Nothing is still there, exactly where it was in 1981, waiting, and we still don't fully understand why it exists. But as unsettling as the Great Nothing is, it's not the largest void we found.
A cold spot in the sky. Deep in the southern sky, in the direction of the constellation Eridanus, astronomers discovered something in 2004 that still doesn't have a fully satisfying explanation. While studying the cosmic microwave background, the faint afterglow of radiation left over from the Big Bang itself, researchers noticed an anomaly, a region of the sky that was measurably colder than everything around it. Not by much by cosmic standards, but cold in a way that didn't fit the pattern. Further investigation revealed why. Beneath that cold patch in the sky lay a void, a supervoid, stretching approximately 1 billion light-years across, the Eridanus supervoid, an expanse so enormous that the Boötes Void could fit inside it multiple times, with room to spare. And here's where things get strange. The cosmic microwave background is the oldest light in the universe. It's the fingerprint of the Big Bang, pressed into the fabric of space like a fossil in rock. When scientists look at it, they're looking back 13.8 billion years, almost to the beginning of everything. That light should have a relatively consistent temperature across the sky, with only tiny fluctuations. The cold spot in the direction of Eridanus is too cold, and the Eridanus supervoid, while it helps explain some of the coldness, doesn't fully account for it. Something else must be contributing. And some researchers, the ones who sleep the least, have raised a far more radical possibility. What if the cold spot is a scar, a bruise left in the fabric of space-time from a collision with another universe? Billions of years ago, before our cosmos fully formed, did our universe collide with a neighboring bubble of reality, leaving this chilling imprint on the oldest light we can observe? The idea sounds like science fiction, but it has been published in peer-reviewed journals. It has been taken seriously by serious people. We don't know the answer. That's what makes it terrifying. If you find yourself fascinated by the idea that the universe may be far stranger than we imagined, you're exactly the kind of person Cosmos Decoded was built for. Consider subscribing, because what comes next makes the void look like a quiet afternoon. The Invisible Hand, the Great Attractor. In the 1970s and 80s, astronomers made a discovery that quietly rewrote our understanding of where we are in the universe. Our galaxy and hundreds of thousands of galaxies around us are moving, not just drifting with the general expansion of the universe. They are being pulled, drawn toward a specific point in space at roughly 600 kilometers per second, and no one could see what was doing the pulling. The region of sky responsible for this gravitational tug was hidden behind the densest part of the Milky Way itself, a zone astronomers call the zone of avoidance, where our galaxy's dust and stars block out the view of anything beyond. Whatever was pulling us was lurking directly behind the one part of the sky we couldn't see clearly. They named it the Great Attractor. The Great Attractor lies roughly 150 to 250 million light-years away, and it appears to be an enormous gravitational anomaly, a concentration of mass so immense that it pulls on everything within hundreds of millions of light-years. As astronomers gradually mapped through the dust, they found it likely contains the Norma cluster, a massive congregation of galaxies, along with dark matter and other structures contributing to its extraordinary gravitational pull. But here's what makes the Great Attractor deeply unsettling. It may not be the final destination. Some research suggests that the Great Attractor itself is falling, moving toward an even more massive structure, the Shapley supercluster, located hundreds of millions of light-years beyond. A cosmic chain of gravitational dominoes, each pulling the next, all the way back to something vast and distant and unknown. Our galaxy is being pulled by something invisible towards something even larger in a direction we can barely see. And there is nothing we can do about it.
The monster at the center of our galaxy. For decades, astronomers suspected something terrifying was hiding at the heart of the Milky Way. The evidence was subtle at first. Stars near the galactic center moved strangely, orbiting at impossible speeds, tracing paths that only made sense if something with extraordinary mass was sitting at the center, invisible, pulling them around it. In 1974, astronomers Bruce Ballack and Robert Brown detected a powerful radio source emanating from the galactic center and named it Sagittarius A. But they couldn't see it, not directly. What they had found was the radio ghost of a supermassive black hole, a beast with the mass of 4 million suns, compressed into a region no larger than our solar system. For nearly 45 years, Sagittarius A was known but unseen, a monster confirmed by the behavior of everything around it, but never directly photographed. That changed in 2022, when the Event Horizon Telescope, a global network of radio dishes acting as a single Earth-sized telescope, captured the first image of its shadow, a glowing ring of light and heat surrounding an absolute darkness at the center. The image was beautiful. It was also a portrait of something that, if our solar system wandered too close, would consume everything we've ever known. Planets, moons, the sun itself, all devoured, compressed, stretched into ribbons of matter spiraling down into the abyss. Sagittarius A is 26,000 light-years away. For now, that distance makes us safe.
The point of no return. Event horizons and singularities. Every black hole has a threshold,
a line in the fabric of space where the rules change forever. It's called the event horizon, and it is the most terrifying boundary in the known universe. From the outside, it looks like nothing. There's no wall, no surface, no visible marker, just a point in space past which the gravitational pull becomes so strong that not even light, traveling at 300,000 kilometers per second, can escape. Once you cross it, you are not imprisoned, you are simply committed to a destination: the singularity. Deep inside every black hole, at the very center, is a point where our understanding of physics completely collapses. A singularity is, according to our best mathematical models, a place where matter is compressed to infinite density, where space-time is infinitely curved, where the equations that describe reality produce results that don't make sense. In other words, a place where the universe breaks its own rules. Einstein's general relativity, the theory that accurately predicts everything from GPS satellites to the bending of starlight, fails at the singularity. Quantum mechanics, the other pillar of modern physics, also fails. We have no theory that can describe what happens there. That gap in our knowledge is the most honest and unsettling thing in science.
The cosmic blowtorches, quasars. Now imagine a galaxy, hundreds of billions of stars spanning 100,000 light-years, blazing with light across cosmic time. Now multiply that brightness by 1,000. That's a quasar, and it can fit inside a region smaller than our solar system. In the 1960s, astronomers were confused by certain objects in the sky. They looked like stars, but their spectra, the fingerprints of light, were all wrong. They were too bright, too far away, and emitting energy at levels that simply didn't make sense for any known stellar process. In 1963, astronomer Martin Schmidt cracked the code. These weren't stars at all. They were the most powerful engines in the universe, supermassive black holes caught in the act of devouring their host galaxies. As enormous amounts of matter spiral into the black hole, the accretion disk, the swirling disk of superheated gas surrounding the event horizon, reaches temperatures of millions of degrees and blazes with energy across every wavelength of light. The jets these systems produce are even more extraordinary. Narrow beams of particles and energy blasted from the black hole's poles at nearly the speed of light, stretching for millions of light-years in either direction. If a quasar were anywhere near our galaxy, its radiation would strip the atmospheres from every planet within range, sterilize any surface it touched, and make the existence of life impossible for hundreds of light-years in every direction. Fortunately, most quasars belong to the early universe. They existed primarily when the cosmos was young and dense, billions of years ago, and are now billions of light-years from Earth. But they existed. They were real. In the universe's past, there were cosmic blowtorches burning with the fury of trillions of suns, and one of the largest ever found, TON 618, contains a black hole 66 billion times the mass of our Sun. Not 4 million like Sagittarius A star, not a billion, 66 billion solar masses. The light we see from TON 618 left it 10.4 billion years ago, when the universe was barely 3 billion years old. We are looking almost to the beginning of time itself, and what we see there is a monster so impossibly large it defies every model we have for how black holes form and grow. How does something that massive even exist? We don't know.
Stars gone wrong. Magnetars.
Not all terrors in the universe are defined by size. Some of the most dangerous objects in the cosmos are small, city-sized remnants of dead stars, packed with matter so dense that a spoonful would weigh 1 billion tons. Neutron stars are what remains when a star between 8 and 20 times the mass of our Sun exhausts its fuel and collapses. They are extreme by any measure. But among neutron stars, there is a subclass that takes extremity to another level entirely. Magnetars. A magnetar has a magnetic field 1,000,000,000 times stronger than Earth's. That's 1 followed by 15 zeros. So powerful that at a distance of a few 100,000 kilometers, it would rearrange the iron in your blood, tear molecules apart, and disrupt the atomic structure of matter itself. So powerful that it can affect Earth's ionosphere from across the galaxy. In 1979, a burst of gamma radiation struck Earth's atmosphere with the energy of 100 billion nuclear weapons, all arriving within a fraction of a second. It came from a magnetar, from 160,000 light-years away. That was 160,000 light-years. In December 2004, a magnetar called SGR 1806-20, located about 50,000 light-years from Earth, released a flare in approximately 1/5 of a second that contained more energy than our Sun produces in 250,000 years. It was the most powerful burst of energy ever recorded from outside our solar system. Magnetars are also unpredictable. They don't warn you. They simply snap, their magnetic fields twisting and fracturing like a breaking rubber band, and release enormous bursts of X-rays and gamma rays in every direction. If a magnetar formed within 10 light-years of Earth, the ozone layer would be obliterated. Life would likely not survive. The nearest known magnetar is about 50,000 light-years away. We believe we are safe. We believe.
Death from the dark. Rogue black holes. Every fear about black holes we've discussed so far has had one comfort built in. We know where they are. Sagittarius A star is 26,000 light-years away at the galactic center. Known quasars are billions of light-years in the distance. Named magnetars have been catalogued. But rogue black holes have no address. When black holes are formed in violent supernova explosions, or when two galaxies merge and their central black holes interact gravitationally, some black holes can be ejected from their host systems entirely, cast out into the galaxy like stones flung from a sling. They drift through interstellar space with no star to orbit, no galaxy to anchor them, silent, invisible, moving. Since black holes emit no light of their own, a rogue black hole wandering between stars is essentially undetectable, unless it happens to pass befront of a distant star and bends the star's light through gravitational lensing, creating a brief, distinctive brightening. In 2022, astronomers using data from the Hubble Space Telescope confirmed what may be the first detection of a rogue black hole, 5,000 light-years from Earth. Now consider this. It's estimated that there could be millions of rogue black holes drifting through the Milky Way alone. Most of them we have no idea about. We cannot see them, we cannot track them, we cannot predict their paths. One could be moving in our direction right now. It would give no warning, it would emit no signal. Its existence would only become apparent through the gravitational disruption of objects nearby, perhaps the alteration of planetary orbits,
the distortion of our sun's pull on the planets, the creeping realization that something vast and invisible was close. Rogue black holes are death from the dark, the universe's most patient hunters.
The pull from beyond. Dark flow. In 2008, a team of astronomers made a discovery so strange, so unsettling, that even the scientists who found it spent years second-guessing themselves. Galaxy clusters, enormous collections of hundreds or thousands of galaxies, bound together by gravity, were moving, all of them in the same direction. Not just nearby clusters, but clusters as far as 2.5 billion light-years away, all being drawn toward a specific region of the sky. But in that direction lay nothing visible, no known structure, no identified source of gravity, just the edge of the observable universe, beyond which we cannot see. The phenomenon was named dark flow. The most disturbing implication of dark flow is this: if galaxy clusters billions of light-years away are being pulled toward something, that something must be almost incomprehensibly massive. And if it's beyond the observable universe, beyond the 46.5 billion light-year horizon of everything we can see, then it is, by definition, something we can never directly observe, never reach, never fully understand. Dark flow suggests that the universe we can see is not the whole story, and that forces we can never directly study are shaping the motion of everything within our cosmic horizon. We may be leaves on a river, flowing toward a waterfall we cannot see and will never understand.
And then there is the boundary, the edge of the observable universe. It sits approximately 46.5 billion light-years away in every direction. Not a wall, not a physical surface, simply the limit of what the speed of light and the age of the universe allow us to see. The universe is 13.8 billion years old, but because space itself has been expanding since the Big Bang, in some regions faster than light, the objects that emitted the earliest light we can detect have since moved far beyond where that light originated. Beyond the observable horizon, there may be more galaxies, more voids, more quasars and black holes and magnetars, perhaps identical copies of everything we know, repeated across a cosmos so vast it would make our observable universe look like a grain of sand. Or perhaps something else entirely. Regions where the laws of physics are subtly different, where constants like the speed of light or the strength of gravity take different values, where atoms form differently and the universe as we know it never assembled at all. The honest answer is, we don't know. We cannot know. The observable universe is all the information that has ever reached us, or ever will reach us. Everything beyond it is, by definition, outside the realm of direct scientific observation. And this is where the true existential weight of this journey lands. The universe we can explore with our best telescopes, our fastest spacecraft, our most advanced mathematics, is not the universe. It is a bubble of light and time, surrounded by an incomprehensible darkness we can never penetrate. Within that bubble, we've found voids so large that galaxies vanish into them, invisible forces dragging everything we know toward unseen destinations, black holes that erase the laws of physics, stars that can sterilize planets from thousands of light-years away, and strange flows of matter pointing towards something beyond the edge of what can ever be known. What does it mean for us? In the most immediate sense, almost nothing. These places are inconceivably distant. The Boötes Void will never reach us.
Sagittarius A asterisk will not devour our solar system for billions of years, if ever. The nearest magnetar is safely remote. Even dark flow, moving galaxies at 600 kilometers per second, will take hundreds of billions of years to change anything we'd notice. But in the deepest sense, everything. Because the scariest places in the universe are not scary because they're going to kill us, they're scary because of what they reveal, that the universe is not the well-ordered, comprehensible clockwork that centuries of science suggested. It is wild. It is filled with things that break our equations. It contains more mystery than certainty, more unknown than known. The universe we can see is 13.8 billion years old and 93 billion light-years across. It contains 2 trillion galaxies, and within all of that extraordinary vastness, there are places where our best theories simply stop working, where the map runs out, where the known world ends and something else begins. That is not a comforting thought, but it is a magnificent one.
What the darkness tells us. We began tonight with a question. What are the scariest places in the universe? The great nothing of the Boötes Void, the eerie cold scar of the Eridanus supervoid, the invisible gravitational pull of the Great Attractor, dragging us towards a destination we can barely see. The monster at the heart of our own galaxy, quietly waiting 26,000 light-years away. The point of no return at the event horizon and the incomprehensible mystery that lies beyond it. The cosmic blowtorches of quasars, fueled by black holes larger than anything our physics comfortably allows. The snapping magnetic fields of magnetars, capable of erasing life from thousands of light-years away. The invisible wanderers, rogue black holes drifting through the galaxy with no address and no warning. The dark flow pulling entire galaxy clusters towards something that may lie beyond the edge of everything. And the edge itself, the boundary of the observable universe, past which no information has ever reached us and none ever will. These places are real. They exist right now, in the same universe you wake up in every morning. But here is the thought that lingers longest. Every single one of the terrifying things we visited tonight was found by human beings, by people who looked up, built instruments, did mathematics, and refused to look away from what the universe was showing them, even when what it showed them was something that defied easy explanation. The great nothing was found because someone mapped the sky carefully and noticed the absence of something. The cold spot was found because someone studied the oldest light in existence and noticed it was wrong. Dark flow was found because someone tracked the movement of galaxy clusters across billions of light-years and realized they were all drifting in the same direction. We are a species on a small planet orbiting an ordinary star in a quiet corner of an average galaxy. And we have managed, with instruments built from metal and glass and mathematics, to reach out and touch some of the most extreme things in existence. The universe may be dark, vast, and terrifying, but it is also somehow a place that produced us. And we looked at it, and we kept looking. The universe is under no obligation to make sense to you, but it is under no obligation to stop being extraordinary either.